Hi friends, nice to meet you. I have promised you that I will come with some funny videos with statistics, and I have already come. And my first video is based on estimation, basically, which is sometimes a life-threatening chapter to some people from belonging from undergraduation and post-graduation and all over the world. It will be helpful for all, I think it will be helpful for all of us who are coming from statistical background, mathematical background, and anything else. They all can understand this video, I think, because I am trying to prepare this video especially for those who are not coming from statistical background, thus that they can enjoy this video. And if you can enjoy this video, please like, share, and subscribe my YouTube channel, thus that it will be spread so much that everyone can be benefited to watch this video. And moreover that your one single like and subscription influence me to prepare a new video. Okay, then I will start my first video. And first of all, I should give my some bit of introduction. My name is Devjay Thakur, and I am pursuing my PhD from IIT Tirupati. Okay, and now I am starting my first video. In this video, I want to share what is estimation and why estimation is required, and how an employee can apply this using the coding, and that's all. Okay, so for this, I am giving you an example, real life example. Here, I have taken the example on the real life data on Kolkata air pollution, basis of Kolkata air pollution. And I have taken 9 metro stations, for example, Shambhajar, Mahatma Gandhi Road, Central, Rabindra Sadan, Jatindas Park, etc. And I have taken the data from 1st January 2014 to 31st December 2019. And in this case, my job is to estimate the pollutant concentration value in the air using a spatiotemporal model. Then many people can ask me, what is spatiotemporal model? Basically, spatiotemporal model is that model which includes the fact space, which is changing on the basis of space and time as well. And that's why we assume that the pollutant concentration value in ith hour and in the jth location in the air dependent on the some independent variables, traffic flow in the intersection part, number of trucks, number of autos, number of heavy loaded cars, and average wind speed, etc. in the ith hour and the specific jth location. And that's why I have tried to build up a linear model. For example, I don't know whether this model is validate or not. This is my rest of my work. Here my work is where exactly estimation is required. In the next video, or maybe the next to next video, I can come the validation of model, and that's all. Here, suppose I assume that the concentration of ith location and ith hour and jth location is dependent on some independent variables, and this is the linear relationship maybe here and that's why the parameters are here a, b1, b2, b3, b4, b5. Now my work is to estimate these parameters. So a student who is coming from non-statistical background, sometimes they may face this type of problems because this is maybe the students who are coming from environmental background. They are doing mainly this type of job. So the student who is coming from mechanical, electrical, physiology, and etc. In every sector, they can face same type of problems, maybe different type of problems. There is some model and there is some parameters, and their work is to estimate the parameters. So now I can tell you exactly what is the estimation and why it is required. So we have the data here on of Kolkata air pollution, and we have some theory. Using the data and theory simultaneously, we are trying to build up some statistical model, and in that model there is some parameter, and our job is to estimate the parameter. But it is not the end of my job. There is some, because after estimation of parameter we should validate the model, and we should validate the estimation also, and adequacy of the model. That's all. There is so many things, but in this video I am just discussing that our job is to estimate the parameter, and how I estimate the parameter, it is our main target. How I estimate the parameter, to discuss this, we should know how many types of estimation in the world. Basically, if we estimate the parameter, suppose the value of, suppose we are trying to estimate the value of A. It can be a point, it can be an interval, anything. So that's why we can distinguish estimation in two ways. One is point estimation and another is interval estimation. Point estimation basically gives a single value using a statistic. Now you can ask me, what is statistic? I will tell you in the next slide. To infer information about the population. Okay. So point estimation is nothing but a single value of a parameter using some statistic, and from this value we infer information about the population. And in the interval estimation, in place of a single value, we are giving an interval which includes the population parameter, considering some margin of error. Here, two terms are used. One is an interval or range which includes the population parameter, and second term which I have used, margin of error. That means there is no single value, there is a range. Okay, so that's why I have given a pictorial representation of this. I give a statistic, and here is the data. From data, I have given parameters A, B1, B2, B3, B4, B5, and using some statistic, maybe sample mean, maybe sample median, maybe sample mode, etc. Sometimes we are trying to give an exact value of that parameter, and that's why I have given a direct arrow. And sometimes we are trying to give an interval which includes the parameter, or range which includes the parameter value. I think all of you can understand what is the point estimation and what is the interval estimation. Basically, the difference between point estimation and interval estimation is point estimation estimates the parameter giving a single value, and interval estimation includes the parameter on the basis of some margin of error. Okay. Now I am coming in the next slide. In this slide, in the previous slide, you have two new terminology. One is statistic, and second is parameter. So, what is the statistic and what is the parameter? Okay. Then come to this slide. The definition of the statistic is function of a sample. Here, the function means the characteristic of a sample. Okay. And parameter is the function of a population. Here, the function means the characteristic. Okay. To understand this in detail, I have given you a pictorial representation. From population, we are collecting a sample using some technique. It may be simple random sampling, it may be stratified random sampling, it may be clustering. The students who are not coming from statistical background, you may be afraid of hearing this terminology. What is simple random sampling? What is systematic sampling? Okay, just ignore. Using some method, I have taken a sample from a population. Understood? Okay. Then what we are doing? From sample, we are trying to define a statistic, which is the characteristic of sample, and which estimates the parameter, which is unknown to us. And what is the parameter? Parameter is the character of the population. So basically, what is, if anyone asks you what is the character of the, what is the parameter, then you just simple tell that parameter is the characteristic of the population and statistic is the characteristic of the sample. Okay. And then a question should come in your mind that, okay, I am telling to take a population, and from the population, I'm telling you to take a sample, random sample. And from sample, you are taking some characteristic of the sample, you are noting down some characteristic, which is statistic. And on the basis of statistic, you are estimating the parameter. Then the question is, can the parameter be variable? Is it possible? Or, okay, entire thing is an experiment. Then how an experiment should be done? This question should come in our mind, and we are noting down. Okay, we will answer this question after all lectures. Okay. Okay. So I think you, all of you have understood statistic, what is statistic and what is parameter and what is the difference between them and how we will take sample from the population. I'm not discussing the all techniques of sample survey. I will tell you it is not coverable in the short lecture, so I will discuss it in the later videos. Okay, just follow. Okay. In the next slide, I will tell you that important types of point estimation, because already we have come to know that there are two types of estimation. One is point estimation and another is interval estimation. Then an employee who are working in TCS or Genpact or any other company, etc., they want to know how many types of point estimation, or in how many ways it is possible to give a single value of the parameter. I'm again repeating, in how many ways it is possible to give a single estimated value of a parameter. And for these, I'm giving you some important types of point estimation. One thing is maximum likelihood estimation, and the second thing is method of moments of estimation. Okay. These two things are too much important and too much useful in all over data science course. So please try to learn and invest your important time in learning these two things and enjoy this. I think all of you are enjoying this. So now first, I will tell you maximum likelihood estimation. Maximum likelihood estimation basically estimates the parameters of a population. How? Parameters of a population. How? By maximizing a likelihood function. It is too much important. Maximum likely. So if anyone asks you what is MLE, or how you assure that MLE is a good method of estimation, then he will tell you, sir, MLE is that technique which estimates the parameter of population by maximizing the likelihood function. Then anyone can ask you, what is the likelihood function? Likelihood function. Some students can tell you likelihood function is nothing but a probability function or joint probability function. No, it is fully wrong concept, and it is important for theoretical purpose. If anyone who wants to use this video for theoretical purpose, they can give importance on this part, because it is too much important for them and it is strictly for them, because here is less enjoyment and high reality. So if you are bored by the definition of likelihood function, probability function, and etc., blah blah blah, then you can ignore. But for theoretical purpose, it is very much handy. So please listen carefully. What is likelihood function? Likelihood function is nothing but a function of a parameters where random variables are fixed in the observed values. Again, I am repeating. Likelihood function is the function of the parameters where the random variables are fixed in the observed value. Okay. Now you can ask me, what is random? And I am prepared, and I want to tell you, random variable is nothing but a measurable function with respect to sigma field and Borel set. Now you can ask me, what is sigma field? Sigma field or sigma algebra is an algebra which is closed under one, complementation and countable unions. Then you can ask me what it means. Algebra means a class of sets of omega or parameter space or the set of all outcomes which is closed under complementation. That means if A, suppose A is a set and belongs to an algebra, I assume that the algebra is script A or script B or script C or script D, etc. Suppose I have taken algebra is script A, then is complement of that set A should be in script A first, and second, if the two sets A and B are in script A, then A intersection B should be in script A. That is the definition of algebra. And if omega, what is the omega? I've said the parameter space or the set of all outcomes. Suppose a coin is tossed, the omega is head tail. If the coin is tossed twice, then the set of outcomes is 4. Why? Because if a coin is tossed twice, then one possibility is 2 times head occurs. Second and third possibility is first time head occurs, second time tail, or second time tail, first time head, and the last possibility is all time tail. That is the omega. And the complement of omega, that is called the null set, it should be in algebra. That is the definition of algebra. And when the algebra becomes a sigma algebra, if it is closed under complementation and countable. Now you can understand what I want to mean countable. Countable is that which is mapping from natural numbers, from set of numbers to natural numbers. Okay. You cannot understand what I want to say. Okay, then I will again again repeating. Suppose AI is the ith set. If I is 1, then in AI is A1, A2, A3. In this way, you have a countably infinite set. An union of all this set should be belonging in the sigma algebra. I think all of you understood. If you are not understanding, then I am repeating again. If an algebra is closed under complementation, number 1, and second is countable union or intersection, then that algebra is called sigma algebra. What it's mean countable union or countable intersection? Suppose ith set is AI, and if I is 1, then A1, A2, A3, A4, A5, A6, A7, A8. In this way, it is countably infinite number of sets, and union of all the sets should be belonging in sigma algebra. Okay. Now I think you have understood. And again, I am introducing another terminology, that random variable is a measurable function with respect to sigma algebra and Borel set. Now you can ask me, what is a Borel set? Borel set is nothing but a set in a topological space. Now you can ask that I'm not completing the definition of Borel set, because Borel set is okay. Then I'm completing the definition of Borel set. Borel set is a set in a topological space that can be formed from open sets through, again, I'm using the term countable unions and its complementation. Okay. If you're not understanding, then I'm repeating again. Suppose I have a topological space. I have a collection of open sets, countable collection of open sets. I'm taking countable unions of these sets and complementation of these sets, and I've formed the Borel set. Now you will ask me, what is the topological space? Okay, I will reply of this question also. What is topological space? A set of points along with set of neighborhoods for each point, satisfying a set of axioms relating points and neighborhoods. That means suppose we have a set of points, 10 points. Let us assume 1, 2, 3, dot, dot, 10. Okay. We are taking a neighborhood of each point, and on the basis of some axioms, we are performing a set, we are creating a set. That set is called topological space. So topological space is nothing but a set of points which is created on the basis of neighborhood concept of each points. Okay. So random variable. So now I am concluding line by line. What is MLE? MLE is the estimation of the parameters of the population by maximizing the likelihood function. What is the likelihood function? Likelihood function is the function of the parameters only when the random variables are fixed in its observed value. What is the random variable? Random variable is the sigma field and Borel set measurable function, or the measurable function with respect to sigma field and Borel set. What is the sigma field? Sigma field is a class of sets, class of subsets of the sample space, or omega, which is closed under complementation and countable union. What is the Borel set? Borel set is a set which is created by taking countable unions of open sets and complementation. So a set in a topological space. So what is the topological space? It's a set of points which is created on the basis of neighborhood concept of each point. Okay. Now I am telling or introducing the new concept, method of moments of estimation. Method of moments of estimation is done step by step. First, we try to express the population moments. Which is the population moments? First order moments is population mean, population variance, etc. Second order population moment, that is population moments. So first we are trying to find out the values of population moments. and then we're equating these population moments to the sample moment. This methodology is called the method of moments of estimation. So, the method of moments of estimation, our first job is to express the population moments in some equation of or in some function of sample moments. So now the persons who are enjoying this and who are not coming in from the statistical background, they can ask, where I will use this? You are telling enough and enough mathematical terminology or statistical terminology you cannot understand. Yes, I know you cannot understand. And your purpose is where you will use, it is your target, and that's why you are watching this video. And I'm trying to satisfy your purpose also, and that's why I'm telling you that when you have the data, you just, your work is just to find out the estimated value of the parameter using these two tools. One is maximum likelihood estimation, and another is method of moments estimation. So now you can ask me how you will perform this using, and then for this there is enough mathematical tools are available. You can code this in any language. Here I am describing two important and well described mathematical tools. One is Newton-Raphson method and another is iteration. In future I will describe what is Newton-Raphson and what is iteration. Okay, mainly these two techniques you can estimate the parameters, or you can give the single value of the parameters in two ways. One is maximum likelihood estimation and another is method of moments of estimation. So now I think already you have bored because I'm discussing with you for a long time, and that's why I'm trying to give you a summary. In the first video, in the first slide, you have understood what is the requirement of estimation. The second and third slide, we are going through what is the statistic and what is the parameter and all. And third and fourth, third slide, most probably, second slide, most probably you have gone through the types of estimation. And in the previous, last slide, I have known that important types of point estimation. And again, I will memorize you what is the requirement of estimation to estimate the parameters of the model. It is the requirement of estimation. And what is the types of estimation? Two types. One is point estimation and another is interval estimation. And what is the important types of point estimation? There is two types. One is maximum likelihood estimation, another is method of moments of estimation. How we will use it? Newton-Raphson and iteration process. Okay. Sometimes you can use import package some packages. This is also available. Now in 6 slides, what you have in 5 slides, what you have learned, you should raise these questions when you will go through this slide. In the first slide, no, in the second slide, when I have told you the definition of interval estimation, I have used the terminology margin of error. Then you should ask yourself, what is the significance of margin of error in estimation. Definitely, it has some role. So, how it plays the important role, you should investigate this. One thing I have told you that you are giving a single value of parameter, and sometimes you are giving a range which includes the parameter value. Then can it be possible parameter being a variable? You should ask yourself. Yes, I think it is possible. Next, you are constructing a sample, you are creating a sample from a population, not sorry, null and statistic and parameter. Then I'm asking you what, how you conduct that experiment, how you conduct that such that performing that it is a population, and in such a manner your cost is will be minimized. That's all, because you should emphasize on the cost of the experiment. So how you conduct the experiment, it has an important role. And the next question is, we are estimating the value of the parameters. Is there any way to check the goodness of the estimated because whether it is good or bad, how can I will understand that? We should ask ourselves. It should have. We should have a way such that we can check the goodness of estimator. And the last question is that we are estimating the value of the parameters. And how I validate this? It should be the important question, because if I am not validating the estimated value of the parameters, then my full uh, my full preparation and everything will be going in vain. So we should check the validate of the estimated value. Okay, so I will come with the next video with the with future plans which I have described. In the next video, I will tell you what is the significance of margin of error estimation. And till you are thinking about this, or if you will get the answer, then please comment. It will be helpful for all of friends, because it is an important thing. Okay, bye, good night, and I think I will meet you soon.